Hi, I'm Alistair, and in this video I'd like to demonstrate how you can use an Arduino to control DMX lighting. Now, there's lots of examples of how you can use an Arduino to light up an LED or control a strip of LEDs like NeoPixels or something like that, but sometimes you want something a little bit more theatrical. And DMX is a standard that's used for controlling stage lighting and effects like I've got behind me. So this makes it a really good way if you want to have, let's say, a spotlight in an escape room. And that's a great way of drawing players' attention to a particular element of the room. I find my attention inexplicably drawn to the two buttons on the wall behind me, for example. So I've got a blue button and a red button, and these are wired to input pins on the Arduino that is controlling these lights. So if I press the blue button, rather than simply having an LED light up blue, I've got the entire room now bathed in blue. If I press the red button, surprise surprise, it's bathed in red instead, and I can sit here and quite happily change the mood of the room. And you could use this as a slightly more dramatic colour feedback mechanism to an Arduino puzzle. But there's lots of other ways you can use it as well. Suppose that instead of having those lighting effects triggered by buttons, I put them on a loop in the Arduino sketch, and maybe I accompanied it with a sound effect as well. Well, if I do that, then you end up with something like this. And you could imagine that being used in lots of scenarios in escape rooms where you want to have the effect of a police car arriving. Or perhaps you've got a room that's set in a secret lab and players have to assemble Frankenstein's monster, and then kind of the ultimate goal is that there's a lightning strike that the electricity brings him alive. Well, we can achieve that as well with a similar method. Now, those examples were directly written on an Arduino sketch, but if you've seen any of my other videos recently, you'll know that I've been using a program called Node-RED a lot to provide a nice graphical user interface, and this is an ideal example to demonstrate what it's capable of, because what I've done is I've created a kind of a Node-RED interface that's a little bit like a virtual lighting desk. So at the top here I've got a colour wheel, and if I move my mouse to like a greeny hue up here, for example, that's sending a message to the Arduino, which is then controlling the DMX lighting to send that hue. And I can turn that pink or I can turn that blue. So you could use this kind of as a real-time method of setting the mood in the room. Or you could have this triggered when a particular puzzle is solved, or when a certain amount of time is left on the game countdown clock, for example, to change the mood of the room. And maybe you could have this as the basis of a puzzle as well. If I just make a slightly more moody atmosphere, it's very common in escape rooms to have players find a UV flashlight, for example, or black light, and have to reveal hidden clues using it. But instead of having the players have a handheld flashlight, perhaps it would be better to actually have UV blackout in the room and have that reveal secret messages hidden that were sort of visible all around. So there's really lots and lots of example uses for this. I think it's great. So let me tell you a little bit more about how it works. So the DMX standard itself is actually pretty straightforward. It consists of one DMX master device and one or more DMX slaves connected together, and collectively that network is called a DMX universe. So the master device is the controller that issues the signals that the slaves listen to, and for that I'm using an Arduino Uno that's got this DMX shield stacked on top of it. Now this shield cost about £15 to £20. It's possible to actually build your own DMX interface for an Arduino for less money than that. I'll put a link in the description if you'd like to do that. But the shield's a convenient way to do it, so I'm just using one of those. And you see that it has sockets there, so it has an output and an input. Now, the slave devices on the network, well, those are the lights and the other effects that you want to control. So here's the spotlight I was using earlier, and you'll see on the back there that that also has an input and an output socket. And so to create your universe, your set of connected DMX devices, all you do is you simply take a cable like this and you take it from the DMX out of your master to the DMX in of one of the slaves, and then you go from the DMX out of that slave to the next slave, and so on in turn. So you're daisy chaining all your devices together. And if I just show that here, so this is the cable I've got going to my lights at the back. And I've now created my universe, starting at my master and going through all my slave devices. Now in terms of the actual data that's sent, what's happening here is that my master device is continuously sending 512 packets of data. And sometimes the standard is actually called DMX 512 for that reason. So they're 512 bytes, and each of those bytes of data can take a value between 0 and 255. Now, every one of the devices in the universe receives all 512 bytes of data. It gets passed between every single device. But how they react to that depends on the setting that you actually make on the slave itself. So let's say, for example, that I am looking to control a light like this that has RGB values. Well, that would use 3 channels of DMX data. I might send channel 0 to be the red value from 0 to 255, channel 1 to be the green value from 0 to 255, and channel 2 to be the blue value. On the light itself, if this is a 3-channel light, I would say that the address, the DMX address that these lights should be listening to is between channels 0 and 2. And I can set all 3 of these lights to listen to those same 3 channels of data. So these 3 lights will always do the same thing because they're all listening to the same channels. This light at the end here, well, this was my UV blackout light. So I don't want to listen to the same channels of data as to my RGB lights. Perhaps for this one, I want to listen to channel 4. And channel 4 might be a brightness value from 0 to 255 of just this individual light here. And then maybe you've got other lights which are on motors. So you might want a channel to control the X and the Y of the motor. Or a fog machine. Well, that might just be a single channel as well, just to say on or off. So you can have up to 512 channels of data, but a channel doesn't necessarily correspond to a single light. Because you might have one light that actually has many channels. These are actually, I think, 7-channel lights, because as well as RGB values, there's also special modes like strobe settings and fading in and out and things like that that are controlled on those extra channels. So these can have up to 7 channels of DMX data. I think this one is a 5-channel device. The Spotlight I was using is a 6-channel device. So there's no particular standard. You'll have to look at the data sheet for the exact lights that you're using as to what channel corresponds to what function on the light. But if you have many lights that are all identical and you want to control in the same way, you can simply reuse the same channels of data for them. So I hope that makes sense. So you can have up to 512 channels, but exactly what that corresponds to depends on the particular lights you're using. And here's the sketch that's running on the Arduino. So at the top I've got 2 libraries which I'm using. This first one here is the library that's going to interface with the DMX shield, and it's based on some code which I found at this GitHub link, though I've actually made a few modifications to it to make it work with the particular DMX shield I'm using. So I've modified that file and I've saved it in the source subfolder in the DMX simple directory of this project. I'm not sure if this is something I've mentioned before explicitly or not, but you may have noticed when you include library files at the top of an Arduino sketch, sometimes you'll use this kind of syntax with speech marks to say the name of the header file, and sometimes you'll see this syntax where you have angled brackets. Now, both of these include additional files in your Arduino sketch that are defined elsewhere. The difference is that this top example this searches for local libraries relative to your project. So like I said, in this example, what I did was I took some code, I made some modifications to it, and then I saved it in the source subfolder of the directory in which this file itself is saved, and then I put it in the DMX-Simple folder within that. So this searches for local libraries of code, whereas this example here, well, this is a library which I installed by going to the Sketch menu and then include manage libraries, and if you search for JSON here, you'll find Arduino JSON library. So this is a library I installed through the Arduino IDE, and you'll see it's designed for processing data encoded as JSON. So if you have a library that you installed through that method, it gets installed in your Arduino libraries folder. And to look for a file from there, you use these angle brackets instead. So they both achieve the same thing. They both incorporate code from somewhere else into your Sketch, but this one is for local files, whereas this one is for sort of globally installed libraries. That's why. The JSON itself, so this secondary library, that's what we're going to use to process messages that we send to the Arduino through a serial link, which I'll demonstrate that in a moment. Okay, so then we get on to the constants. So the constants are values which are not going to change throughout the duration of the sketch. We define the pin that we're going to transmit DMX messages from on the Arduino. And also there's a pin which we use to select whether we want the Arduino to be a master device or a slave device. So in the example here, I'm only using it as a master, but in theory you could also have it acting as a slave. So perhaps you've got a prop that you want to trigger by a DMX message. So for that one you'd want to set it into slave mode instead. And those two buttons which I used in the demonstration at the beginning, well, those are going to pins A0 and A1. In the setup function, we begin a serial link, and we also send some information to that serial link, just some sort of help text to explain how to send values to the Arduino. That's what that is. We configure the Arduino to run in master mode, so we write a high output to that mode select pin, and we also tell it to use the specified pin for transmitting DMX messages. So what that means is the Arduino is going to send messages to that pin will go to the shield, and the shield will send the appropriate messages through the DMX interface. This bit here, so like I said, DMX messages always contain 512 bytes of data, or up to a maximum of 512 bytes of data. The library here actually only sends those bytes that have been used. But some DMX slave devices I found don't work correctly unless they actually receive all 512 bytes. So this is just a sort of setting to make sure it works with those kind of devices. We initialize our pins just as normal, and that's the end of setup. So then we go into the loop function. And in the loop function, I've kind of demonstrated two different ways that you can use an Arduino to control DMX lighting. So this top example here, this is how I was pressing the buttons and setting the colours of the lights to that red and blue effect. If the blue button has been pressed, so remember I'm using input pull-up, so I'll do a digital read of the blue button, and then if that is low, which I'll do the exclamation mark, then we're going to write 4 channels of DMX data. So the particular lights I'm using there, the very first channel they listen to, that's an overall brightness value. So I'm going to set it to maximum brightness on channel 1. And then the following 3 channels, that's where it receives the RGB values. So to set a pure blue colour, I'm going to set channel 2, that's the red channel, to 0. Channel 3 is the green channel, set that to 0 as well. And channel 4 is the blue channel, which I'm going to set to max. So that sends a maximum blue signal to my lights. And then if I press the red button, well, you can see it does a very similar thing. This time though, we're going to set maximum brightness to 1, maximum value of the red channel this time to 255, and we're going to clear out the values on channels 3 and 4. So by default, the library I'm using here will retain a channel value until it is overwritten by something else. So we actually have to explicitly set a blue value of 0 here because we set it as 255 here. We don't want to keep the blue value here because otherwise we'd end up with purple. We'd have red and blue on. So we actually have to explicitly send a 0 value when we want to turn a light off. So that's one way you can control the lights, by sort of manually writing to these channels in the sketch. But if you want to do something a little bit more complicated, this is where that JSON library comes in useful. So what I've done here is I'm going to see whether any data has been sent to the serial link. So this is the USB connection on my Arduino. And if any data has been sent to that, so that could have been sent from the serial monitor, the Arduino IDE serial monitor, or it might have been sent by something like Node-RED, which has got a USB serial connection to the Arduino. Well, if any data has been sent there, what we're going to do is we're going to use that Arduino JSON library to pass any JSON data available. So we'll create a new document, we'll attempt to deserialize it, and we'll just find out if any error has occurred in the process. If it has, we'll dump out the details of the error. If it hasn't, that means we've received some valid JSON document in the format that we were expecting. So remember, we wrote that at the top here. So we've got a channels object, and that contains an array of channel values and the value that we want that channel to take. So what we're going to do here is we're going to look through that array. So we'll look through the channels array. And for every element in that array, which we'll just call V, just as an iterator, we'll take the channel, which is an int, we'll take the value of that channel as an int, and then we will call that DMX-simple method, and we'll write whatever the value is to the corresponding channel. So this is a bit complicated, but all this is doing really, ultimately, is writing this DMX-simple message here, which is exactly what we were doing up at the top here. But instead of hard coding a channel and a value, or a set of channels and values, what we're doing is we're looping over a JSON array, and we're pulling out the channels and the values it specifies, and then writing them one at a time. So let me actually show you why you'd want to do that. If I just turn on my monitor window again, so you can see the lights on behind me, and now if I load the serial monitor up. Okay, so we've got the serial monitor connected to the Arduino, and we've got that little help text at the top that says this is the format that it expects to receive data in. So if I now just copy that and paste that into the top bar here, so this is how we send serial data to the Arduino. If I send that, what you'll see is we'll get a little bit of output information. So it's set channel 1, remember that was the overall brightness, to maximum, and we set channel 3, that's the green, to halfway, 1 to 8, that's midway. Now let me take the channel value out for channel number 1, and this time let me turn channel 2 to halfway. Now send that message. Now what I've got here, I'm hoping this is coming across, I've kind of got an orangey light. So this is a combination of green and red, because I've turned the red on all the way. Now let's turn 3 down to 0. Oops, 3 down to 0 even. And let's turn channel, I've lost track of where I'm up to. Let's turn channel 2 down to 0. And now all the lights have gone off. And finally, let me turn channel 4 up to maximum. And you see I'm now in blue light. So what I hope that sort of demonstrates is that you can send these quite complicated JSON messages that have they don't have to send the entire 512 bytes of DMX data they want. All you have to do is send the channels that you want to change at that moment in time, and the Arduino Sketch will go through the data, pass out the channels that you specified, set the values that you want, and it will combine it with whatever existing value was there. Now, as you probably noticed in that last section, the problem with using the Arduino serial monitor to enter values is that I was struggling to remember what channel corresponded to what colour, and as you add more and more devices into your DMX universe, that obviously gets harder and harder. So that's where you really need to have some kind of front-end interface, and this is where I'm going to turn to Node-RED. So I've used Node-RED in my last couple of videos. If you're not familiar with it, do go and check it out. It is free and open source, and it runs in a browser, and it's a great way of connecting different devices together. So here I've got the Node-RED flow, which I use to create this little kind of user interface which I showed at the beginning of the video. So I'll try and step through what's going on here. I'm actually going to start at the end because this is a node that I haven't used before. So this is a serial node, and it's not included in the palette by default. So the first thing you're going to want to have to do is go to the menu here, go to Manage Palette, and if you go to the Install tab and search for serial, you need to install this module here. So this lets Node-RED talks to serial ports. And when you install that, you'll get some new node types on the sidebar here. So you'll get serial in, serial out, and serial request. So I've got a serial out at the end of my flow here. And you can see that all you have to do to use it is you specify the COM port you want to go to, and the speed and the data parity and baud rate and things like that. So I'm using COM4 at 9600, and that is exactly the same setting as you would set in the Arduino IDE. So where I was here and I had my port, I was selecting COM4 and 9600 as specified in the code here. This is exactly the same, but now rather than trying to communicate with the Arduino from the serial monitor in Arduino, now I'm going to be communicating it from the end of my Node-RED flow. So that's the end point of my flow here, and you'll see that all these other flows sort of lead up to that same point, which is ultimately to deliver a DMX message in that JSON format. So let me just sort of step through what's happening here. So at the start here, I've got a couple of events. The first one happens after 5 seconds after the flow is loaded. I found that my my DMX shield needed a little bit of a time to initialize after it was first turned on. So rather than doing it immediately after startup, I'm just going to give 5 seconds just to make sure it's totally initialized itself before I do anything else. And you'll see then I've put that to a link out node that goes to this and this flow here. So this flow at the top here, this is all about setting the brightness, so that was all on channel 1, remember, and this one underneath it, this is all about setting the RGB values, which are on channels 2, 3 and 4. The reason I've separated them out into different flows is because I've got them based on different UI elements. So my brightness is a slider which I've got up here, so that sets channel 1, and then channels 2, 3 and 4 are based on the colour wheel I've got here. So that's why I've separated them onto different flows here, because they're using different inputs. I've got two other events which I defined at the top here. So I've got a save button, very simple, just a button, and when I click that, I'm going to change two variables. So I'm going to set something called saved brightness, I'm going to set to the current brightness, and saved colour I'm going to set to the current colour. Seems easy enough, you'd think. And when I hit the restore button later on, you'll see that that comes to links here. That goes to these bottom two nodes, and that simply restores the saved brightness. So I'm going to inject a message from the saved brightness, and this one is going to inject a message from the saved colour. So what that means is that if I actually just turn my little video capture on again so you can see me here. So if I move this slider over to the red area, let's say, so you can see I've got a red light coming out, and I'm going to save that. Now let's move over somewhere else. Let's move to the light blue area, and I'm going to dim the lights a bit. When I click restore, what's going to happen? So I'm going to go back to that bright red area again. Come up here to green, restore. So it's basically just saving whatever value, and I can overwrite it. Let's save a light blue. Come over to yellow, turn the brightness up, and now when I restore it goes to light blue. So this save and restore here, you can have many of these if you want. You could actually save a whole array of different settings, different preset lighting moods that you want, and then very quickly click between them using a single button. So that's what they do there. So they inject values into this flow here. So I'm either going to restore a saved value, or I'm just going to have an initial value. My initial brightness is 200, so a little bit off maximum. And my initial RGB value, this is 80, 80, 80. Well, that's basically midway. That's the hex way of expressing midpoint, basically. So a hex value goes from 00 to FF, so 80 is kind of midway. Then, like I say, we've got these two different UI elements. So the brightness is on a slider. The color wheel is on for the RGB values here. And then based on whatever value those UI elements are set to, we set the current brightness based on the payload of those nodes and the current color. And then this bit here, so this is where we actually build up that JSON message. So remember, this is exactly the same format as what we were just sending in the Arduino Serial Monitor IDE. We're going to build it up, so we've got a channels object that contains an array, and this top line, because we're only responsible for setting the brightness in this line, so we're just going to set channel 1 to whatever the value of the brightness has been set by this flow, which in turn basically is what's come out of this UI element. And then that sets channel 1, and we'll pass that to that serial output that's going to send it to the Arduino. This one here, this is a bit more complicated, because here we're setting channels 2, 3 and 4. So these are our RGB values, and they were set based on the value chosen in this UI element here. And once we've assigned those, well, they'll get passed to the serial output, so to the COM4 output as well. Okay, so that's our kind of ambient lighting. The next sections are all about the kind of special effects. So let's have a look at the UV blackout, for example. So this is a simple button, and when we press the button, what we want is we want to turn all of the other lights off and the UV light on, and then we'll wait 5 seconds, and then we'll revert back to the state we were at before. So this trigger node here, what this does is this is going to send true for 5 seconds, and then after that it's going to say false. So we can kind of think of this as a Boolean value to say, hang on, is the UV blackout active at the moment, true or false? And we'll send that into a switch node. So if it's true, we're going to go to output 1, that's the top one. If it's false, we're going to go to output 2. So here's output 1, here's output 2. So we'll go to this node first. And so if we want to turn the node on, we're going to set the payload to this. Now this looks slightly more complicated, but it's really not. And remember, this is very specific to the exact DMX lights you're using and the channels they use. So I won't go into too much detail. But remember that channel 1, well, that was the brightness for my ambient RGB lights. And when I turn my UV light on, I want to kill all those lights. So I'll set channel 1 to 0, because that's going to kill all the normal lights. And then my UV light actually has, confusingly, 4 channels assigned to it. It behaves as if it's an RGB light, in fact, although every one of the RGB values has a UV LED in it instead of a coloured LED of that value. So 11 is the overall brightness, and then 12, 13 and 14, which would be the RGB values, are actually all just UV lamps. But we're going to set them all to max. So that's going to turn on my UV light. And again, once we've done that, we'll send that to the serial output. And when the trigger goes off again, well, this is then going to send a false. So this is how we come back to where we were before. So to do that, I'm going to set 8, 9 and 11 to 0. So let's turn off all the UV lights that we just had one. And we'll restore the ambient lighting to whatever they were before we put the floodlight on. So that's what this bit does here. So we'll retrieve the previous variable brightness from the flow and we'll put that back into channel 1. So that goes to where we were before. We also have a sound effect that we wanted to trigger. So this is a kind of a magical sound effect. So here I've got a file node, which is somewhere on this side here. So we've got a file node which loads a WAV file from the hard drive and it sends it to the audio output. So this is my speakers and it's going to play that sound effect at the same time that the UV blackout is triggered. That obviously doesn't need to go to the serial monitor because it's going directly to the audio out assigned to this device. So that's kind of my first special effect. So I will just show you that in action just to remind you again. So we've got our ambient lighting, which I'll just set to some value or other. So I'll set it to red just so it's nice and obvious. When I press the UV blackout button, what will happen is the main brightness will get killed, the sound effect's played, the UV light comes on for 5 seconds, and then we're returned back to how we were. Okay, so the lightning strike, well that's similar but not quite, because for the lightning strike we don't just want to turn on a light for 5 seconds and then turn it off again. What we actually want to do is send a whole sequence of different brightness intensities to the lights. So we'll do that in a function node here. So I've created an array. This is my sequence of lightning strikes. So we'll start off with a sort of a mid-range value, go up a little bit, down again, and then we have a very bright strike here that actually lasts for kind of 2 values, because it's obviously a bright one. Then that recedes gradually, and then we go all the way back to 0 again. So you can kind of change this pattern however you like to kind of match the sort of the style of lightning storm you want to try to emulate, I guess. And then what we're going to do is I'm just going to set up a loop here that loops over each of those variables, and it sends to channel 1 whatever the next variable is in the array. So we're going to go over the array one at a time, send that as a channel 1, so this is the brightness overall. And my lightning I want to be kind of, mostly white, a little bit of a blue colour. So I'm going to send channels 2 and 3 to be very high. They're the red and green channels. They're nearly full but not quite. And my blue channel, that's going to be maxed out. So this is going to be a bright blue, bluey white flash that follows that sequence of intensities. So we'll do that, and we'll use this node.send command in the loop to send a whole series of message payloads with those values. And then once we've sent them all, the final thing we want to do, well again we want to restore whatever the previous value was before we started that lightning storm. So just as before, we'll get the colour variable from the flow, we'll get the brightness variable from the flow, and then we'll send one final message that just restores channels 1, 2, 3 and 4 back to wherever they were before. So that's the lightning strike. And again, I'll just remind you what that looks like in practice. So we'll stick with red. So we send a series of different intensities, we play an audio effect at the same time, and then when it's over, we go back to where we were. And again, we've got our audio there, and we've got an audio here with the police siren. The police siren, again, it's a slightly different method, so I'm just sort of trying to show you lots of different ways that you can achieve these effects. So what we have here, again, we have a loop that we're going to iterate over, and channel 1 is always going to be maximum brightness. Channel 3, which is the green channel, is always going to be 0. But channels 2 and 4, well, they're the red and the blue channels. What we want to do there is alternate between which one of them is on. So I've done this little modulo expression here. So this means that if we are on an odd number of the loop, then I want to set the red value to maximum, and if it's even, we'll set it to 0. And the blue channel is completely the opposite. So if we're on an odd number of the loop for blue, we'll set it to 0, and if it's even, we'll set it to maximum. So they're just going to alternate which one of the red and the blue is on. Again, we'll use node.send to send that message, and finally we'll restore whatever value we had before. So that's that. And again, we've got a sound effect. Now, the thing is, the loop here, this is going to loop very quickly, and if we just left that exactly as it was, we probably wouldn't be able to notice those individual red and blue turn on and off. So we need to limit the rate of change somehow. So that's what this next node here is. So this is a delay node, but we've set it to limit the rate of messages that are allowed to be passed through it. So what I put is I put 2 messages per second. I don't actually know how fast a police siren lights change, but that's kind of what felt right to me. But obviously you can alter this however you want. You could set it 2 per day. That'd be a very slow police car. So whatever, again, adjust that for whatever effect you're trying to achieve. And then finally at the bottom, I've got the spotlight. The reason I included that was, again, just to show a different sort of control. So my spotlight is a very simple toggle switch on and off, which just goes between 2 values. So the spotlight itself sends true or false. That then goes to a switch node. So true goes to the top output, false goes to the bottom output. And then if it is true, we turn the spotlight on. Now my spotlight is using channel 15 as its intensity here. And you see it's got these other channels. Like I said, even a simple light that you'd think would only have a single channel to it often has extra sort of modes. So you need to check the datasheet for each device you're using. And when we turn it off, we simply set channel 15 back to 0 again. So that is my complete kind of lighting rig kind of interface emulated in Node-RED, which has got sort of all these functions. So you can set the lights, you can set the brightness, you can have saved presets that you can then restore later on. You can turn individual effects on and off, and you can have special effects, which you can launch like this. So that's just a brief introduction as to how you can use an Arduino to control DMX lights like these. And if you run an escape room game and you're looking to create a more impressive theatrical set piece, let's say, I think this would be a really good way of doing it. I'll include in the description below some links to some of the products I've used, the shield and the lights and things like that. And I'll also upload all the code I've demonstrated to my Patreon account as usual. If you'd like to support me to create more projects like this, and if you're able to do so, please do head over to my Patreon page. I really enjoy creating these videos, and I will carry on putting them up here for free anyway. But if you would like to support me to create more in the future, that would be amazing. If you have any questions or comments as well, please do let me know below, and I'll do my best to get back to you. Otherwise, I'll simply say thank you very much for watching, and I'll see you next time. Okay, cheers, bye.